Hello, this is Mr. Anksman, and these are your notes for section 7.1. These are the learning goals, and you'll want to copy these down. So the first one is I can identify on the periodic table atoms and elements that will gain or lose electrons to form ions. I can describe how anions and cations will form, the part on ionic bonds. You'll talk about that in a later section. I can predict the charge that will be formed as an atom becomes an ion. And I can produce electron dot structures for single elements. The parts on ions and ionic compounds will cover that in section 2. All right, so this first part on valence electrons, if you feel pretty good about valence electrons, I don't think you need to copy these notes down. So we've seen this for a couple chapters now. But in general, the number of valence electrons of a representative element is equal to the group number. So we can just get the number of valence electrons from the group that element is in the periodic table. Okay, and then this, you don't have to write this part down either, but valence electrons are the electrons in the highest occupied energy level. And they're the electrons that are in the S sublevel, the highest energy S sublevel, or the S and P combination. So you can also get the number of valence electrons from the electron configuration. So it corresponds with the A group number. The reason we talk about valence electrons a lot is because chemistry is mostly about valence electrons. They are the electrons that are involved in making chemical bonds. So they're the electrons that are either transferred or shared when chemical bonds are formed. Okay, now this part you want to write down whether you've heard this before or not with the valence electrons. But you want to start copying down all this information. You do not need to write down the information in the bottom in these two tables, but you want to get this right here. So we have the octet rule. When forming compounds, allows atoms to achieve a stable 8 valence electrons, or octet, like a noble gas. So this is the reason why atoms will either gain or lose or share electrons. So this is why they react. So in these next two chapters, we're talking about the different bonds that atoms will form. This is really the reason why, because they're trying to gain the octet rule and be stable like the noble gases. So metals will lose their valence electrons to reveal a lower full energy level, and nonmetals will gain or share their valence electrons to get to a stable octet or 8 valence electrons and be like the noble gases. You also want to write all this information down. This is kind of the new content for this section on electron dot structures. So you want to be able to write electron dot structures for elements, and this allows us to visualize valence electrons, and we'll use this a lot in these next couple chapters. So electron dot structures, they show the valence electrons and potential bonding scenarios, whether it would be an ionic bond or a covalent bond. So in an electron dot structure, it's going to show the element symbol, 1 or 2 letter symbol, and that represents everything but the valence electrons. So that represents the nucleus and what's called the inner core electrons, everything but the outer valence electrons. And then we use dots, which will be surrounding the symbol, and those represent the valence electrons. So we use dots to represent the valence electrons. This is an example of what it looks like down here. You don't have to draw that picture yet. We'll see this on the next slide too. Now when you put the dots around the symbol, you can really start anywhere, but put 1 electron on each side before you begin pairing them up. Okay, so something like carbon with 4 valence electrons, you wouldn't pair up these electrons until you have to. You just put 1 on each side, 1 on top, bottom, left, and right. Okay. Now these are the dot structures that you should write out. So this table shows electron dot structures for atoms in some group A elements. I would pause the video and draw out all the period 2 elements. Okay, so you see what it looks like for anywhere from 1 up to the 8 valence electrons. So just draw all these out for period 2. And then all the elements that are in the same group on the periodic table will have the same electron dot structure, just a different chemical symbol in the middle. All right, so pause the video and draw out all those in period 2. Okay, now the last few slides for this section are about cations and anions and how they form. So you want to record all this information on this slide here. Okay, so cations are positive ions, and they're formed when electrons are lost or given away. This happens with metals, and they have 1, 2, or 3 valence electrons, and they're going to lose those electrons to get to the next energy level down, which has a full octet rule. So when we start off, atoms start off neutral, and by neutral we mean the protons are equal to the electrons. So when the metals lose those electrons, now we have more protons, so the ion is going to have a positive charge. Okay. Now we also want to start looking at the names of these. A cation name is going to be the same as the element name. So like these two examples down here, when the sodium atom loses that electron, we still just call it sodium. You don't change the name at all. So the magnesium ion, we just call it magnesium. Okay. Group 1A and 2A metals lose their S sublevel electrons, and this is what it looks like. Sodium starts off with the 1 valence electron. It's going to lose that electron, and then in the process it forms a +1 charge. Magnesium starts off with 2 valence electrons. It's going to lose both of those to become stable, and in the process it forms a +2 charge. So always write the charge of the ion in the upper right corner. Okay. And then you want to know on your periodic table, the group 1A metals all form +1 ions because they all have that 1 valence electron that they lose. And the group 2A metals all form +2 ions. So make sure you have that on your periodic table. Okay, and then along with the cations, there's also the transition metals. Now the problem with transition metals is they don't have really a set rule, because they have d electrons that do a lot of different things. So you want to record this information down here on the left side. So it's a complicated movement of electrons in the d region, and they may not follow the octet rule. So like I said, they do some different things, so they don't have like a set rule that we need to know. They can form a lot of different charges, anywhere from +1 up to +7. And for most of the elements in the transition metals, they can form multiple charges. For example, you have iron can form a +3 or a +2 ion. So quick question, you can pause the video and think about this and answer this one, but how does an alkali metal like cesium atom form a cation? And the answer is going to be letter C. Cesium has the 1 valence electron, so it's going to lose that electron and form a +1 ion. Okay, and then for the nonmetals, you want to copy this information down. Okay, the nonmetals in the upper right part of the periodic table, they're going to gain electrons to become like the noble gas and become stable with the octet rule. And then you want to record all this information here too. This shows the electron configuration and how a chlorine atom gains an electron and forms this chloride ion, okay, and has the same electron configuration as the noble gas that's right next to it. So it forms the octet rule. So anions are negative ions formed by an atom or gaining or taking electrons from something like a metal. So the nonmetals, they usually have 5, 6, or 7 valence electrons. So it's easier for them to just gain electrons to fill up that outer energy level and gain that octet rule. And remember, the atoms start off as being neutral. So now when these nonmetals are gaining electrons, it's going to form a negative charge. One thing with the name, the anion names will end in "ide." Okay. So the cation names, we didn't change those, but the anion, now that's going to end with an "ide." So something like fluorine, when it gains that electron, it turns into the fluoride ion. Okay. Now with the notes, you don't have to necessarily draw this picture down here, but make sure you get the name change from fluorine to fluoride. And same thing with chlorine to chloride. And I would draw this down here into your notes. All right. So that's all for the notes for section 7.1. Have a great day.